A muscle cell has different structures, and the first one is the sarcolemma, which is the cell membrane of a muscle cell. It's not just cell membrane, it's a special form of cell membrane. And in muscle, we call it sarcolemma. And the second one is the sarcoplasm, which is the cytoplasm. It's equivalent to the cytoplasm in muscle cell. And in addition to that, muscle contains contractile proteins, which are the actin and myosin, or the thin and thick filaments. And muscle also has regulatory proteins, troponin and tropomyosin. I don't expect you to understand how a muscle functions fully, but at least I want you to understand the background information about it. Now, as you remember, there are four kinds of tissues. We have the muscle tissue, epithelial tissue, connective tissue, and nerve tissue. So muscle as a tissue has various components, and the first component is the fascia. Fascia is the outer covering, the white covering of a muscle tissue. And inside the muscle, inside the fascia is the muscle fascicle. This is the entirety of the bundle of muscles. We call it muscle fascicle. I was trying to find a good analogy to explain what epimysium, perimysium, endomysium, and the muscle fiber are. So I don't know if this is if this works for you or not, but I'm gonna try. So as I have told you, fascia is the white covering of the muscle fascicle, or the whole muscle tissue in general. And inside the fascia, we have different structures, and the outermost layer is called the epimysium. So if you assume just this whole muscle tissue as the United States, the epimysium is it is the US boundary in general. Like the boundary that the border we have with Canada, Mexico, even in the Atlantic Ocean and things like that. This is the outermost boundary of the fascicle. And on top of this, this epimysium is the white covering, or the fascia. Now, even though we have a boundary as a country, there is a boundary for every state. So the perimysium is the boundary for every state. And as you know, we have 51 states, I guess. So the perimysium is the outermost boundary of a multitude of bundles of muscle fibers. Look the word here, a multitude of bundles of my muscle fibers. It's not just bundles of muscle fibers. We have a multitude. We have 50 plus bundles of muscle fibers, or in reality, we have thousands of thousands of bundles of muscle fibers. So this is the state boundary. And then we have the endomysium, which is the boundary for a county. This is the outermost boundary of a bundle of muscle fibers. And as you know, in each state, there are several counties. And the last one is the muscle fiber. These are the individual muscle cells, or you can assume every individual in the county or every single house. So this is a muscle fascicle, from muscle fiber, endomysium, perimysium to epimysium. And I want you to take a look at the slide. I'm sure it's going to be more clear when you go over and look at it. On top of this, each muscle contains blood vessels and nerves associated with it. It's like the county. In every county is not just people that we have a lot of things. Fascicle organization by shape. Fascicles are organized into different shapes. We have circular fascicles. When we say fascicle, we are talking about like bundles and bundles of muscles. So it could be circular, like the muscles of the mouth, or it could be parallel, like the muscles of the abdomen, in particular what we call the six-pack. Those are parallel muscles. And we have Convergent muscles. Convergent muscles are muscles that converge at one end. Let's say if you take a triangle and if all muscle fibers are pointing toward one end of the triangle, that's what a convergent muscle fascicle looks like. One typical example is the pectoralis major or the chest muscle. And we have the pennate. These are probably the more complex kinds of fascicle organization. And here the muscle fibers are attached to the tendon obliquely. They are not attached parallel or circularly or in a convergent way. They are attached to the tendon obliquely. And they don't have very definite shape. One typical example is the deltoid muscle or the shoulder muscle. Pennate muscles, they have their own categories. We have the unipennate, pennate, the bipennate, and multipennate muscle fascicle. So you don't need to know all the details, but just know that fascicle organization can include circular, parallel, convergent, and pennate. Attachment points of muscles. Why is not going down? Muscles have attachment points. It has always endpoints. Let me see if I can go down. I don't know why it doesn't let me go down. Okay, attachment points of muscles. Muscles have two endpoints. Okay, come on, I got it. Okay, the origin is the stationary end of. I got it, but for some reason it's not going away. I think my Chromebook gets stuck. Okay. So the origin is the stationary end of muscles and the insertion is the movable end of the muscles. And we have three different types of muscles. We have the agonist, the synergist, and the antagonist. The agonist is in every muscle movement, there is an agonist. An agonist means the prime mover of a particular skeletal structure, because as you know, muscles usually move certain kind of skeletal structure. So there's a prime mover, that means the primary participant in the movement. And then we have a synergist that aids the prime mover. And we have the antagonist that works against the agonist. So I don't expect you to understand or to come up with examples, but just know the different types of muscles. And the other concept is motor unit. For those of you who probably take the MCAT, there might be questions about the motor unit. A motor unit it refers to muscle fibers that are innervated by one motor neuron. One motor neuron might innervate probably hundreds or thousands of muscle fibers, and that just unit is called motor unit. And if you have two motor units, and if these two motor units innervate the same muscle fibers, you could say two motor units. And the last topic for today is the sliding filament model. This is a model of muscle contraction or how muscle contracts. To just put it in plain words, this is when thick filaments pull thin filaments, and when the whole muscle gets shortened, and that whole process is called contraction. I'm not going to ask you with details because I'm sure you are going to go over this thing or probably in the next bio classes. since this is probably the first bio class you take, I don't expect you to know the details, but know these things. Muscle contraction requires ATP, energy, and ATP has to be broken down into ADP and phosphate because this is adenosine triphosphate. We have three phosphate molecules. So when one of them is broken down, it's going to assist the whole muscle contraction process, and you get adenosine diphosphate. You have two phosphate molecules and a phosphate ion. And calcium also plays a huge role in this whole process. Oh, I guess that's all you need to know. Wait, I'm sorry about this thing. It's not going away. I tried it. Okay.